Okay, so it says to evaluate the following. So kind of like the warm-up, we don't have equations, we have expressions. And so we need to evaluate them, which essentially means simplifying. So we've got log base 7 of 7 raised to the blob power. The blob is 3x squared plus 2. It's a function of x. Any recommendations on what that is equal to? X? We could put that to the floor for a vote. How about let's write our properties that we just talked about on the warm. Sometimes it's good just to have it in front of you. Log of any base of that same base to the anything power is just equal to that anything power. Remember, x could be a variable like x, or it could be a number like 5, or it could be a function of x like 3x squared plus 2. Yeah, good. The other one, I'm just going to finish writing it, and then we'll go back to what you said. It works the other way around. So yes, that's exactly what we have. We have log base 7 of 7 to the blob. Well, that should just be the blob, right? That's 3x squared plus 2. The exponent can be anything. In this case, it's a function of x. So quadratic binomial, which is fine. Can we simplify 3x plus 2 any further? No. Okay, no. All right, letter B. Take about 10 seconds and do that one. Yeah, so that was the answer. That was the answer. Yeah, that's it. It almost seems like now what? Well, now we go into part B. That's it. We're just practicing. We're practicing recognizing things. Go ahead and do that one. I'm inspecting the ceiling tiles. Yep, they're still there. Yeah, they're kind of dusty. How would you read that? Would you read that as Lenny? Natural log of e to the x. Good. The natural log of e to the x. So when we have the natural log, it's really log base what? Base e, right? So we don't have to write it like this because the ln is the equivalent, but sometimes, especially in the beginning when we're novices, it's helpful to rewrite it like that. So now really what we're staring at is log base e of e to the x. What is that equal to? That's equal to x. Good. So the goal is to be able to just look at ln of e to the x and say, oh, that's just x because ln is base e, without having to rewrite it. Now what? Go to part C. Sehr gut. All right. Take 10 seconds. Do that one. If we played a pop game right now of The Floor is Lava, y'all would all lose y'all's feet. Yeah. Wofford would survive. The floor is lava. Yeah. That's not as good a rumor to start, right? The floor is lava. Pass it on. I've been in this room for like 15 years, and sometimes you just notice different things when you take on a different perspective. It's kind of nice. What did y'all get for part C? 5? Well, let's see. If we look at this second version, if we have starting with the exponential, b raised to the log base b's power of blob is just blob. So over here we've got 5 raised to the log base 5 of a quantity blob. That should equal what? 5x, the blob. Yeah. Yeah, so that's doing the property on the other side, right? But still the inverse nature, right? Because what we're really doing, if we were to evaluate this, we would start with 5x. We would log it base 5, which would take us, let's say, over here to the right. And then we take that result and exponentiate it base 5, which takes us right back where we started over here on the left. And we started with 5x. Okay. Letter D, you do. 5 seconds. What's e to the natural log of x? It's x. Good, because that is really e raised to the log base e of x. Okay, so again, that's the same property we used over here. We're just doing it with base e. And we're going to be using base e quite a bit, so try and get you comfortable with that. Yeah, it's just x. All right, log base 22 of 22 to the x. 1 second. What'd you get? X. Very good. Picking up on things, right? Yeah. Letter F. Half a second. What'd you get? X. Very good. 57 to the log base 57 of x. Good. So that row was pretty easy. It got easier as we went from left to right because we started picking up on the patterns. The patterns, of course, are using these guys here. Muy, muy importante. ¿Sí? Sí. Sí, ¿verdad? All right. Example 3. Evaluate the following. Okay. Log base 5 of 1. 0. Any other answers? Good, that's correct. We know that's correct because of two ways. We can set it equal to x, and then we can convert it. 5 to what power is 1? 5 to what power is 1? Well, the answer is 0, right? 5 to the 0 power is 1. Or we can use that property. If I can write 1 as a power of 5, I'll have it. Well, that's 5 to the 0th power. Okay? In fact, any number to the 0 power is 1. So what we said yesterday was if you look at the graph of y equals log base 5 of x, what is the x-intercept going to be? Not 0, 1, but 1, 0. And it doesn't have to be just base 5. We saw yesterday at the very end of class that for any log function of the form log base b of x, where b is either between 0 and 1 in decay or is greater than 1 is growth, they're all going to pass through the point 1, 0. Just like the inverse function y equals b to the x always had a y-intercept of what? 0, 1. One of them has an x-intercept of 1, 0. The other one has a y-intercept of 0, 1. You remember how we find inverses? Algebraically, we do what with x and y? We switch them, and then we solve for y. That's what happens here. The x and the y-axis actually interchange. And the point 1, 0, when you switch it becomes 0, 1. Pretty cool. All right. What's log base 1/2 of 1? 0. Good. What's log base b of 1? 0. Because b to the 0 is 1. Good. What's log base 12 of 12? Ooh, that's different. Is it 1? Yeah, it's 1. Why? Because they cancel each other out. Yeah, but what is the exponent on the argument? 12 to the what power? 1th power, right? So that's really using this one again. Log base b of b to the x is just x. Okay? What's log base b of b in general? 1, because that's b to the first. Very good. What's the natural log of e? 1, because that's really, again, log base e of e to the first. Good. Good. See, so how we're reinforcing properties with different bases. What's log of 10? Whoa, hang on. What base is that? It's not showing there. Ah, very good. Remember, if it's not showing and it's log, it's implied to be 10, and of course that's 10 to the first, so log of 10 is 1. Very good. Very good. All right, summary of what we've done so far. The top one is the conversion formula. If log base b of y equals x, then b to the x equals y, and vice versa. Log of any base of 1 is 0, and log base b of b is always 1. And if that exponent is more than 1, like b squared, it's going to be 2. If it were b cubed, it would be 3, so on and so forth. We can summarize that with the one below. Log base b of b in general to the x power is x. And then we can flip the operations around. B to the log base b of x is also x. Very good. Y'all starting to like logs? Yeah. They're not just for keeping you warm in the winter, right? And by that I mean some people used to burn their math textbooks to stay warm because they hated logs. Okay? Yeah, so if you actually don't have like wooden logs, math textbooks with logs in them was the next best thing. But y'all are starting to like logs, so you would cherish those math textbooks, not burn them, right? Okay, good. Unless you were like dying and you need to stay warm, then you could say that logs, when you burn them, it's a worthy sacrifice, because in that case, the logs are giving you life. Ooh, logs give me life. As I already mentioned, our TR calculators are pre-programmed to handle which two bases? E and 10. Only E and 10 directly. Bless you. And then if we looked at the second keys on those, we saw it was e to the x and 10 to the x, and of course it wasn't a coincidence. It was because they were inverses. So what would we do then if we had something like log base 2 of a number, like 5, and we wanted to evaluate it? Okay? Does anyone know approximately? That's an awesome pumpkin. Would anyone know approximately what this answer will be? 2 to the what power is 5? Very good. 2 squared is 4, right? And 2 cubed is 8. So it's going to be 2 point something, right? It's going to be between 2 and 3, because 2 squared is 4. And it should be closer to 2 maybe than 3, because 2 squared is 4. 5 is closer to 4 than it is to 8. So how can we figure out those other decimals if our calculator only handles base 10 and base E? Well, if all you've got is a hammer and a screwdriver, you have to start making everything look like a nail or a screw, right? Right? Am I right? Yeah. Okay, so the hammer would be, I guess, base 10, and the screwdriver would be base E. If all we have are base 10 and base E, we have to start making everything look like something that is base 10 or base E. So we have to be able to change the base from base 2 to base 10 or base E. And good news, there is a formula for changing the base, and it's called, appropriately enough, the change of base formula. If you're in Ireland, they call it the change O base formula. Okay? But it's very, very similar. All right? You ready for it? Here's what it says. It says if you have log base b of x, and you don't like base b, or you want to change base b to something else, feel free. You can change it to base e by doing the natural log of x, the argument, over the natural log of b, the base. The natural log of x over the natural log of the base. Now notice it's easy to remember which one goes on top. The x goes on top, right? And the base goes in the bottom. Base, bottom. Both of them start with what? B. Very good. So the base goes in the bottom. You can also see the way it's written in the problem. The x is written a little bit higher than the base because the base is a subscript. So notice the x is higher than the base, so the x goes in the numerator. So that's one way to do it, okay? The other way to do it is if you don't like base e, that's a shame because we're going to be using it a lot. But if you want to use base 10, it also works with base 10. Take the log base 10 of the argument over the log base 10 of the base, and you'll get the exact same answer. Now, if those ratios are the same, does that mean that the natural log of x is the same as the log base 10 of x? If two ratios are the same, does that mean that their numerators and denominators have to be equivalent? No, because you could have like 1/2 equals 2/4, right? And 1 doesn't equal 2 and 2 doesn't equal 4. But the ratios are equal. In fact, if you don't want base E or base 10, you can pick any third-party base, call it base A, and you can change it now to log of your new base of the argument over log of your new base of the old base. Okay, so it works for any base. We're just probably going to want to use base E or base 10 because our calculator has that. All right, so let's see how that's done. If you would like to arise from your desk and grab a calculator, now would be the time to do that. Or if you have one sitting at your desk in your backpack or something, feel free to grab that one as well. And if you don't have one, that's also okie dokie. because you can just look on. If we're out, we're out. I apologize. I water those calculators every day thinking they're going to grow into more calculators, but they never do. Okay, so let us return to this problem here. We know that log base 2 of 5 is 2 point something. Here's how we're going to write it. We're going to write it as the natural log of 5 divided by the natural log of 2. And that should give it to us, right? The natural log of the argument, notice 5 is bigger, b is base, it's in the bottom. And so now that I've written it on my iPad paper, I'll write it in my calculator. So from the home screen, hit alpha y equals. Use the horizontal division bar. ln is found to the left of 4. Notice it's going to open the parentheses for you. So get in the habit of closing them, and then cursor to the bottom, and do the natural log of 2. Close it. And then I like to click to the right and just look at it and make sure it matches my paper. So but for the parentheses, it's exactly the same. We should get 2 point something if the calculator is worth anything, right? Hey, we got 2 point something. So how many decimals do we report? 3. So 2.321. Now there's a real quick, easy way to check. We're saying that 2 to that power equals 5. We could check real quick. 2 caret. And now to recall this answer without storing it, you just hit second negative. Second negative recalls the answer from the previous line. And with all those decimals stored, we should get 5. And we do. Well done, calculator. All right. Now, does it work with log base 10? I don't know. Let's see. Alpha y equals. We got log log of 5 divided by log log of 2. Let's see if we get the same answer. Hey, we get the same answer. So do I care when you're doing the change of base formula which log you use, base E or base 10? No, your calculator handles both of them. But you would be doing yourself a greater service if you start using ln, the natural log. Because we don't really use log base 10 in here except for some scientific applications. Mathematicians use base E. It's the analysis number. So in calculus, you won't even see log base 10. So start getting comfortable with log base E. All right. Now, having shown that to you, this is how I want you to do it because it reinforces the change of base formula, which we are actually going to use in a different capacity for transformations. But if you hit alpha window, that's alpha F2, alpha window, this is a nice little menu. Look at menu 5. Look at menu number 5. It says log base. Look what it does in math print. It gives you little boxes into which you can type not just your argument, but also your base. So you could type in a base 2 for the subscript and a 5 for the argument and hit enter. And you get the same answer. But you know what? If you do that, it takes all the freaking fun out of using the change of base formula. In fact, guess how your calculator computes that number? It uses the change of base formula. Yeah. Just with the math print, they gave us the option now of circumventing the change of base formula for an input and just inputting it like this. But it still computes that using base E or base 10. I'm not sure which one it uses. Okay? So that's there to check yourself. Like I said, the change of base formula we will be using for other purposes. So make sure you know it, right? Natural log of the argument over the natural log of the base. All right, sweet. So having said that, let us go to example 4. And on your calculator, I want you to do these 3 questions, but I want you to use the change of base formula, okay? In fact, I want you to do 2 things before you go to the calculator. Number 1, think about a reasonable answer. And number 2, write down the change of base in terms of base E. All right, I'll give you a couple minutes to do that. Just do those three right there, A, B, and C. Don't use log base. Use the change of base formula. I don't even know why I showed it to you. Gosh. I like that color. Did you spray paint that? Or did it come like that? I haven't seen the pink one. Did you get it online? Oh, okay. There you go. You know how to use the Inspire? Yeah. Okay. Works pretty much the same. Okay. No, that's just what this originally thing is equivalent to. So it's, if we would have set it equal to X in the beginning, that would be X. Yeah. It's just an equivalent number. That number is the same as that number. Okay. In other words, 1/2 to the negative 3.807 is 14. So if you want to say that equals X, and that equals X, and that equals X because you want to attach it to something, you can do that. Oh. Otherwise, it's just equivalent number. Yeah? Yeah. Yeah. I would prefer you still work straight down instead of going sideways, and then you don't need the equal sign. But yeah, that's yeah. You've earned it, right? Yeah. Get in the habit of using ln, the natural log. As I said yesterday, it's a much healthier option. All right, I'm going to guide you through these. The part that maybe some of y'all forgot to do is thinking of a reasonable answer first. So our base is 1/2. If you want to set that equal to X and convert it, I'm going to change 0.5 to 1/2. So we're saying 1/2 to some power equals 14. All right. Well, if I let X be a positive number, what's going to happen with 1/2? 1/2 to the first is 1/2. 1/2 squared is 1/4. It's going to be getting smaller. I don't want it to get smaller. I want it to get bigger, right? So how can I make the 1/2 into a 2? What type of value of X would I need? A negative. Okay, if I flip it, it's going to be a positive 2, so X is going to end up being a negative number. And now let's think about a power of 2. Okay, 2 to the first is 2. 2 squared is 4. 2 cubed is 8. That's still too small. 2 to the fourth is 16. 16 is now too big, right? So it should be around 3 point something, yes? It should be negative 3 point something. That's about as good as we can get without a calculator. So what I want you to do then is always try and have it written on your paper before you go to the calculator. So if you set it equal to X, that's fine. You don't really need to. But that's the natural log of 14 over the natural log of 0.5. And then you can go straight to your calculator. Let me make some room here. And again, if you didn't set it equal to X, that's fine. I'm just going to delete that. If you work straight down, remember, you don't need equal signs for these expressions. So now, alpha y equals, I'll do the natural log of 14, close parentheses, and then divided by the natural log of 0.5. If you want to check yourself with the log base command, because it's more user-friendly, that's exactly why they put it on there, feel free to do that. But don't do that instead of the change of base formula. So if you work straight down, negative 3.807, we know that's correct, yeah? So the other way to check it is just think of what a reasonable answer is before you start, and when the calculator lands in that reasonable zone, pretty good chance it's correct, all right? The other way to correct it very quickly is then to say, okay, 0.5, which was my base, raised to that power, which is second negative, that gets the answer, should give you 14. So by checking it that way, you're reinforcing what a log is, right? A log is the exponent to which you must raise the base to get your argument. All right, the next one, log base 6 of pi. So again, I'm going to say 6 to the pi power is equal to x. I'm sorry, 6 to the x power is equal to pi. All right, so if I just let x equal 1, I already have 6, which is bigger than pi. So to make 6 smaller, I need to do what? If I make it negative, right, if I make it negative, it's going to be 1/6. That's already less than 1. So to make 6 just a little bit smaller, I'm going to have to like take the square root of 6, right? Which will be like 1/2 or 1/3 cube root. So it should be a decimal, all right? So my x, I know, should be some kind of small decimal. So let's go ahead and write it. It's the natural log of pi over the natural log of 6. You don't need parentheses around those when you write it down on your paper. The calculator just automatically puts them. So alpha y equals, natural log of pi. And again, when you're using the pi, use the pi button, which is second caret. It has more values stored. And then the natural log is 6. Natural log is 6. Yeah, there it is, 0.638. All right, so that is a fraction. So that's a little bit more than the square root. Okay, so let's check it. We're now going to take the base 6, and we're going to raise it to that power, and we get 3.141592654. And y'all recognize that as what irrational number? Pi. Yeah, cool. All right, and then letter C, we've got 3.6. I'm going to come down here. 3.6 to what power equals 17? Well, 3.6 is 4-ish, right? 4-ish. So 4 to the first is too small. 4 squared would be 16. That's still too small. 4 cubed would be 64. So 3.6 being a little bit less than 4, this answer should be approximately what? 2 point something, right? 3 was too big, so it should be 2 point something. So on our paper, we'll write the natural log of 17 over the natural log of 3.6. And here we go, one more time. Alpha y equals the natural log of 17. Close it, and then divide it by the natural log of 3.6. Big bucks, no whammies. We get 2.211, which was right in the region where we thought it would be. Okay? Oh, we might as well check that, right? We might as well check that. 3.6 was our base. Notice it could be a fraction. And we raise it to the answer's power, second negative. We get 17. If you just raised it to the 2.211 power, you're going to get something really close to 17, okay? But if you use the answer, it's storing all those decimal values, you should get right back to where you started. All right, so we are developing some agility with logs today. All right, example 5. I don't think we'll need the calculator for this. Although you could type it directly in. Simplify the following using the change of base formula, okay? So this is a question that I could give you without a calculator, and the hint here is to use the change of base formula. So notice we have log base 3, log base 2, log base 7, log base 5. None of those bases are the same. They're all multiplied together. How should I start? If it says to use the change of base formula, yeah, we should probably start by writing every single one of those factors using the change of base formula. And what base do we choose to use? Natural log. So that's the natural log of 5 over the natural log of 3 times. Go ahead and do that all the way through and see if anything reveals itself to you. Is it my favorite problem? My favorite problem was the f of x plus h minus f of x over h. But when I say my favorite problem, that kind of is a redundant term because I could literally say that about every problem. Yeah. Yeah. I don't hear any sound effects going on, but I do see some of the sound effects happening. Yep. Yeah. My new hall pass is not the vest anymore. There's a little ruler over here in the chalk tray where the vest used to be, and it just says Corpy Hall Pass. So if you ever need to use it, yeah, that's fine. Huh? I put it in the cabinet there. People weren't wearing it. They were just carrying it. So I'm like, if they're going to carry it, I'll give them something else to carry. Right. Even though I washed it every 5 years, people were still like, ew, it's gross. Right? I don't want to wear that. All right. Actually, probably every 6 years I washed it. Okay. So it's the natural log of 7 over the natural log of 2 times the natural log of 3 over the natural log of 7 times the natural log of 11 over the natural log of 5. All right. So what does that do? It puts them all into base E, but it also creates quotients, right? And we know that we can always divide out common factors, even if they're not side by side, by the associative property multiplication. So what happens with your natural log of 3s? They divide out. What happens with your natural log of 5s? They divide out. What happens with your natural log of 7s? They divide out. And you're left with the natural log of 11 over the natural log of 2. Now from here, if you wanted to get a better answer, you could go to the calculator. Or can we put that back into a single log expression? Yes. Okay. One thing that we haven't done yet is use the change of base formula in reverse. But it does work in reverse, right? So I can rewrite this as log base what? Base 2 of 11. Yeah. So that could be a simplified version. Now, is that going to be an integer answer? I don't know. Let's see. 2 to what power is 11? 2 to the first is 2. That's too small. 2 squared is 4. 2 small. 2 cubed is 8. 2 small. 2 to the fourth is 16. Too big. So this should be approximately what? 3 point something. Yeah, 3 point something. So if this were like a multiple choice question and you didn't have a calculator, if there was only one answer that said 3 point something and all the rest of them were like 4 point something, 5 point something, 2 point something, you could pick the right answer out of the group without even having a calculator, right? So let's go ahead and see what it actually is now. We'll go to the calculator Medora, the Explorer, and alpha y equals natural log of 11 divided by natural log of 2. And you get 3.459. Yeah, there you go. There you go. Now, if you went back to the original thing and you typed all of these things in using the log base command, you know, the version that cheats and gives you the subscript box, you'd get the same answer, okay? But again, doing that takes all the fun out of a problem like this, right? That's why we're here. We're here to have fun. We're not here just to complete tasks. That's boring, okay? That's boring. Okay, tomorrow we will start with example 6, where we're solving equations. And by starting, I mean after our non-pop quiz. We'll have a quiz tomorrow, again as well, just like the amazingly hard pop quiz that we had today. I hope everyone's listening to this going, what? Okay. Your quiz tomorrow could be anything through example 5. Of course, I'll probably have you simplify some of the expressions like we did in the warm-up. I could also have you do what? Use some of these properties to simplify, like examples 2 and 3. And probably for sure something using the change of base. So whether it's with the calculator or without, just practice on the worksheet, come to class tomorrow, ready for the quiz, quick quiz, and then we'll jump into example 6. I don't know if we'll finish tomorrow. If we do, it'll be awesome, but it'll be highly unlikely. All right, any questions before we go to our next class? I hope you recover from today's quiz. I hope it didn't take too much out of you. But if you want to leave the room like looking exhausted and looking spent, maybe tears in the eyes or something, so that second period can buy into the rumor. Have fun spreading the rumor today, guys.